Welcome to this section of this course. Today we are going to speak about differentiation and integrations of the exponential functions. So I'll be explaining by giving some examples of differentiation as well as integrations. Okay. Let's take a simple example. Let's say y equals to e raised to x. Okay. Here y is function of x. Now, if I want to differentiate this with respect to x, then this will be d by dx of y is equals to d by dx of e raised to x. Okay. Now here d by dx of e raised to x is same as e raised to x. Okay. Here, therefore, differentiation of e raised to x is e raised to x. So there is no change at all. Okay. Now, if y equals to e raised to ax, what will be its differentiation? Okay. Now, then dy by dx will be this. Okay. Now, e raised to ax is as e raised to x into, okay, this ax we have to differentiate with respect to x again. Okay. Now e raised to ax is x as it is, and d by dx of ax is, since a is constant, so a will come front. Okay. Therefore a into d by dx of x is 1. Therefore e raised to ax into a. Okay. So let's take an example. Say if y equals to, let's take an example of y equals to log of 1 plus e raised to x upon 1 minus e raised to x. How to differentiate this type of exponential functions? Okay. Now here we are getting exponential function. Here we have log functions. Okay. Now we can solve 2-3 ways by using, number one, by using log property, such as log of m by n is same as log m minus log n. We can apply that formula, or we can use directly logarithm, differentiation of the logarithm. That is, if y is same as, if y equals to log of x, then dy by dx is 1 by x. Okay. This formula we can use over here, or we can use log property, that is log of m upon n is equals to log of m minus log of n. Okay. So let's try two different ways. So before differentiating this, I can write by using this log property. Okay. That is same as log of 1 plus e raised to x minus, because of this formula, log of 1 minus e raised to x. Okay. That is y. Still I have not differentiated it over here. Okay. Now from here I can differentiate with respect to x. Here you can say differentiating with respect to x, we have dy by dx on the left hand side. On the right hand side, here we have log of 1 plus e raised to x. You can consider this as some term. Okay. Or you can say u, something like. So log of this is same as 1 upon whatever it is, 1 plus ex. Again, this with respect to differentiate with respect to x. Okay. So this d by dx of 1 plus e raised to x is, d by dx of 1 is constant 0 plus e raised to x is e raised to x as it is. So d by dx of 1 plus e raised to x become a e raised to x minus. Same as over here. Since log is there, log is 1 by x, whatever it is over here. So it will be 1 upon 1 minus e raised to x Again, d is differentiate with respect to x. Okay, here will be 0, differential constant is 0, minus e raised to x. Okay, here we are getting minus e raised to x. Okay, here we can do LCM, or you can keep as it is. Here another way is to differentiate is over here is, if second method you can say is equals to, I can here dy by dx. Okay, dy by dx is same as, since log is less, consider this whole term as a one term, or you can say u, there will be log of u. Okay, so since log of u is same as 1 upon whatever it is, whatever the term we have is 1 plus e raised to x upon 1 minus e raised to x into, okay, into this we have to differentiate with respect to x. Okay, into d by dx of 1 plus e raised to x upon 1 minus e raised to x. Here this will go up, 1 minus e raised to x upon 1 plus e raised to x. Here d by dx of something like u upon v. Okay, here quotient rule we can apply. We have quotient rule, that is d by dx of u upon v is v square v d by dx of u minus u d by dx of v. Okay, here this formula we can apply over here. If I apply here, this is denominator numerator, here this will be 1 minus e raised to x the whole square, applying this formula v square. So this keeping as it is, 1 minus e raised to x. Again differentiate this with respect to x. 1 plus e raised to x is what? 1 is constant, e raised to x is e raised to x. Okay, 0 plus e raised to x is e raised to x. Okay, minus because of formula. Here again, here 1 plus e raised to x into d by dx of this. Okay, here 0 minus e raised to x. Okay, here again minus e raised to x. Now if you multiply, you can multiply here each term over here, each term over here. Again you can multiply and cancel from this term. Okay, here we can solve two different ways. Okay, one is by using log property and another is without log property. This is for differentiation for some exponential functions. These are basic exponential functions. Okay.